Alright, so this is the last video on solving systems of linear equations with three variables. And so it's also the last video of the unit, so that's good. And let's go ahead and let's do another example. So we've already had one problem where we had one solution. We had one where we had no solution. And then this last one, if you probably are going to guess, is just going to have many solutions or infinitely many solutions. And so the way you write this last problem, the answer to this last problem is kind of different. So let's take a look at it and work through it. So here we go. So let's start off by numbering our equations. So we got one equation, our second equation, and our third equation. Okay, and so again, I'm going to look at my different equations here. I got 1, 2, and 3, and say which ones are going to eliminate probably the easiest. And so let me say probably I'm gonna have to multiply. I'm gonna take equations 2 and 3, and basically what I'm going to do is I'm going to eliminate the y. So I'm going to multiply these two by this equation by 2. So I have a positive 2 and I have a negative 2. So let's see what happens when I do that. Okay, so I'm going to multiply this by 2, and what do I get? So I guess let's multiply it. So 2 times x is 2x. 2 times y is 2y. 2 times z is 2z. And this is equal to 0. Okay, and let's go over here. Let's just rewrite this one here. So I have x minus 2y minus 2z is equal to 0. Okay, and I guess this needs a z over here. This 2, I forgot this z. That's a z, just remember that. And so let's go ahead and add these equations together and see what we get. So 2x plus 1x is 3x. Negative 2y plus 2y, those go away. And I'm left with 0. Negative 2z and positive z, those also go away. So that's kind of a good thing. It's always good when two things cross. That's always a good thing. It saves you time. And so all you're left with is 0, right? And so that's fine. So I'm going to solve this. We'll see that goes, and just divide by 3 on both sides, right? And that goes away, and so x is equal to 0. So I got one of my solutions, right? X is equal to 0. Great. Okay. And so what do I do now? And so all right, so this is kind of an interesting thing. So we got just one. We've used only 2 equations. We already solved one. So what do we do in this case? Because this will happen to you. And basically what you're going to do is you're going to, if you ever, get down to one variable, if you solve for a variable and you've only used 2 equations, it's kind of a different process. You're going to take that x value and you're going to plug it into either one of these 3 equations, into 2 of the 3. It doesn't matter which one. So let's pick equations 1 and 2, and we're going to plug x equals 0 in for x, okay? And so, if you can visualize that in your head, if I plug in 0 for this x, 0 times 2 is 0, that x is going to go away. So what I'm going to be left with is just y plus z is equal to 0. And if I do the same thing for the second equation, I plug in 0 for x, I get 0 minus 2y, so that 0 goes away, right? We just have minus 2y minus 2z equals 0. And so what do we have to do here? We still have to find y and z. And so how do we do that? Basically what I'm going to do is I need to make one of these variables opposite. So I'm going to make the y's opposite of each other. So this is a negative 2y. So I need to make this a positive 2y. So what I'm going to do is I'm going to multiply this whole equation by 2 and see what happens. So if I multiply this whole equation by 2, what I'm going to do is I'm going to write it right underneath it. So imagine this isn't here anymore. We're just going to box that. We're going to multiply this, and we're going to rewrite it right underneath it. So 2 times y is positive 2y. 2 times z is positive 2z. And 2 times 0 is 0. And let's see what happens. Okay, so negative 2y plus 2y gives me 0. Negative 2z plus 2z also gives me 0. So I'm just going to keep that 0. And then 0 plus 0 is 0. And so what do we have here? We have 0 is equal to 0. And you say, is that true? And you say, yes, obviously that's true. So what does that mean? Okay, and what that tells me is I have many solutions. I have infinitely many solutions. There's not just one solution. There's infinitely many. Okay, and so this is where you could write many solutions, but if you wrote that on the test, you're not going to get full credit. So this is kind of where the tricky part happens, right? The solution. And so again, let me just restate this. The reason this is many solutions and not no solutions, when we had no solutions, we had something like 0 is equal to 2, and we said that's not true, so there was no solution. But when you have an equality that is true, okay, when you have 0 is equal to 0, 1 is equal to 1, negative 3 is equal to negative 3, negative pi is equal to negative pi, or whatever, then you have many solutions. Okay, and so then we got to learn how to write the actual answer to the problem. And so, the way you write an answer is for a system of three equations, you write the three order pairs. So you have 0, comma, we need our y value, and we need our z value. And so that's kind of where it gets a little tricky. So what you do is you take one of these equations that only has two variables. So I'm going to rewrite this y plus z equals 0 over here. So y plus z equals 0. And what you do is you solve for one of the variables. So you can either solve for the z or you can solve for the y. And so basically, you say I'm going to solve for y, and I'm going to subtract the z to the other side. So we'll have y is equal to negative z. Right? All I did there was subtract the z to the other side. So what does y equal? Y equals negative z. So for the y part right here, right, it goes x, y. So this right here is going to be negative z. Because we solved for y, and we got y is equal to negative z. And then what does z equal? Well, z just equals z. Okay? So you want just one variable to be in this order pair. You can't just write 0, comma, y, comma, z. It's got to be just one variable. It's either just y or just z, or if it's an x, it's x. So you have to solve for it and put everything in terms of one variable. So again, this is how you would write the solution for a system of equations with three variables if it has many solutions. You don't want to just write many solutions. You want to write your answer like this. Okay, and so again, you take one of the equations with two variables in it, solve for one of the variables. So in this case, we solve for y. And so y equals negative z, and that's what I wrote in that case of y. Okay, and then the z was just z. Okay, and so that's the final video of this unit. If you have trouble with this, and these are kind of difficult, make sure you rewatch them and watch them until you understand. Okay?